Okay, now it's asking us about concavity because, well, it's asking about points of inflection and then about concavity. So to answer both of those questions, we're going to have to take a second derivative. So we are going to do f double prime x. And I've rewritten f prime x from the first video because it's going to be easier to do the power rule if we write this as a negative exponent. So we now have negative 1/3 times 8 times x to the negative 1/3 minus 1, and negative 1/3 minus 1 is going to be negative 4/3. And then the derivative of negative 4 is just 0, so now here's our second derivative, and we can simplify this as negative 8 over 3 times x to the 4/3. And let's go ahead and rewrite that as negative 8 over 3 times the cube root of x to the 4th. So where are our potential points of inflection? Well, there's no place where f double prime is equal to 0. There's no x value we can plug in and get 0. But if we plug in x equals 0, we are going to get an undefined second derivative, which means that that could be a place where the concavity switches. 3 times the cube root of 0 to the 4th is undefined. So when we make our table, we should go negative infinity until 0, and then 0 until infinity. We're going to talk about f double prime, and then we're going to use it to describe f. Okay, so the first thing we should do is we should plug in a x value within that interval to our second derivative. So we'll do f double prime negative 1. And that's equal to negative 8 over 3 times the cube root of negative 1 to the 4th. So I think we can agree this is going to end up being positive 1 because we have the cube root of positive 1. And that's going to be times 3. Oh my gosh, that might be the worst 1 of all time. Okay, here we go. Positive 1. So that's going to give us negative 8/3. So the second derivative is negative from negative infinity to 0, so we have a concave down function. So next, we should try to plug in x equals 1, because that's going to be in our second interval. So we'll try that now, and we'll do f double prime 1. And I think we should be able to see this is going to be no difference, because now we're just going to do the cube root of positive 1 to the 4th. So this is still going to be negative 8/3. So the second derivative stays negative and stays concave down. So then what we're finding out is that there are no points of inflection, no POIs, because f double prime never changes signs. Okay, so then for part D it says, for what x values is f concave up? F is never concave up. F double prime is never positive. And we've shown that in this table. It's concave down, and then it must have some kind of like vertical no concavity, and then it's concave down again. So that is our final answer.